Computers are impressive devices which has become a part of our lives that living without them has become unimaginable. They are everywhere you look. They are in our pockets, on our wrists. But have you ever asked how do they work? Well, if you are here, then you probably did or wondered. So with this series, we're gonna look under the hood of a computer to find out how does it do what it does. Welcome back to Electronics. This is the first video on series How Computers Work. Let's start from the basics and look at what is electricity. To find out, we need to take a look at an atom. Everything from the screen this video is displayed to the air you breathe are made up from atoms. A single atom is so small that it's impossible to see with the naked eye. So let's use this representation of the inside of an atom called Bohr's model. There are more accurate models that involve quantum theories, but this is more convenient. Inside the atom, there are protons and neutrons, which forms the nucleus at the center of the atom. The number of protons inside an atom is unique for one type of an atom. There are many types of atoms, 118 to be exact, which you can find in a periodic table. The nucleus is surrounded by electrons that orbits around it. These electrons have a negative electric charge, while the protons have a positive electric charge, but the neutrons has no electric charge. The orbits which electrons move, which are also called shells, has different energy levels. Higher the energy level, larger the radius of the orbit, and further the electrons to the nucleus. Each shell can only hold a fixed number of electrons, which is 2 times n squared for the nth shell. The electrons in the outermost shell are known as valence electrons. These electrons are the farthest away from the nucleus, so they can become loose and move away from the nucleus. These electrons are called free electrons. Atoms are stable when they have the same number of electrons and protons, bringing the net electric charge of the atom to zero. But if an electron becomes loose, making it a free electron, the net electric charge of the atom becomes positive. The opposite happens if an electron gets inside another stable atom, making the net electric charge of the atom negative. These atoms are called positive or negative ions. They are unstable in this state and always try to bring their net electric charge to zero. The more electrons they lose or acquire, the more they try to become stable. Positive ions try to attract electrons, while negative ions try to remove electrons from its orbit. Let's take 3 atoms. One is a stable atom. The other 2 are positive and negative ions. Why did I arrange them in this way? You'll see in a moment. If you remember, the positive and negative ions always tries to become stable by attracting or freeing electrons. So in order to become stable, one electron from the negative ion gets freed and become a free electron, which then get inside the stable atom in the middle, while the positive ion grabs an electron from this atom in the middle. In the end, all 3 of them become stable. But if we look again closely, you can see electrons moved in this direction. Or you could say electrons moved from the negative ion to the positive ion. This can happen even when there are more atoms and ions. You can see the electrons move from the negative ions to the positive ions. We can also use electrons in place of these negative ions to make the same thing happen. This is electricity. So, if we get an atom, remove one or more electrons, and then keep them at 2 points, we can move electrons from one point to another and we can make electricity, right? Well, sort of. You see, before when those electrons moved from negative ions to positive ions, they did that because those electrons could move in or out of the atoms easily, or because their ability to generate free electrons easily. Most of the materials do not have this ability. The electrons are tightly bound to the atoms, which making free electrons a lot harder for them. These materials are called electrical insulators. Some of the examples would be rubber, wood, plastic, and air. The materials which has the ability to make free electrons are called electrical conductors. Most of the metals are great electrical conductors, so we can move electrons from one point to another, but in electrical conductors. It's still possible to conduct electricity through insulators, but very weakly. The thing that stops or slows down these electrons from moving is commonly known as resistance. Even in the conductors, there is a very small resistance, but it's insignificant. So then, let's take a conductor like copper wire and start conducting electricity. But wait, we need some ions and electrons. We can get exactly that by using a battery. Inside the battery, chemical reactions happens so that at its negative terminal, electrons are generated while the positive terminal gets positively charged. In this way, batteries convert chemical energy into electrical energy. So, we have all the things we need. But to look at how we can conduct electricity with them, you have to wait until the next video. Until then, you can check out the previous video if you want to know more about this series. If you like this video, give a thumbs up, or if you have any questions, leave a comment down below. And don't forget to subscribe so you don't miss any future videos. That's it for this video. Thank you so much for watching. I'll see you soon.